ME444 Group 1. My name is Tim Checkeye. This is Alex. This is Max. And this is Harrison. Alright, so the story behind this toy. When I was a young child, I used to have battles with my plastic army men in the snow and the grass and everything. They'd be clashing forces side to side. Then, you know, just throw some fireworks in there, light them on fire every once in a while. But something was missing. With plastic army men, you have to do everything manually. And that you couldn't shoot anything actually, you had to just imagine it was going on. So we knew we required something. So the missing components to that fun were we needed something that was remote controlled. It had to shoot projectiles of some kind, and it needed to be able to drive and should be able to be aimed, just like these similar toys in the picture. So some of the ideas we came up as a group were either creating like a military LAV out of the toy, it has all the functions we required, or create the Gustav cannon shown in the bottom left corner there. So we ended up choosing the Gustav cannon, and we based this on the functions that we wanted and the marketability. So this definitely satisfies the requirements of a destructive child like I was, but as an unintended use, it could also be used for beer pong in college. Just imagine one of these at each end of the table behind your cups, and you fire them and try and get it in the cups. I think that'd be pretty awesome. So after we came up with the design, we created the CAD. And as you can see in this picture, it does have tracks. It drives on the tracks. It has a rotating turret, and the cannon can even fire. So here we'll show you a little what the CAD model does when the cannon rotates. Oh, let's go. All right, so yeah, so it rotates, and this can rotate about 360 degrees back and forth. So now we'll show it to you. Okay. All right, so it has a little bit of difficulty driving, which we realized when it's acrylic on acrylic, so that'd be something we would change in like a final product. But then you can see the turret does rotate, which is pretty neat. So that's kind of the actual physical demonstration there. So we can skip the video of it doing that. And so now we'll show the cannon actually firing. So let's see if it shows the video. It's kind of difficult to see in the video if it starts going. Okay, yeah, so it's kind of hard to see, but there's a bevel gear system, and then this is a rack and pinion, and what it was kind of difficult to model how it actually works in CAD because this bevel gear, or rack and pinion, is actually half gear, half cam. So when the gear part will bring the rack back, which as you can see here is with rubber bands or could be a spring in the future. And then once it hits on the actual part, there's the flat cam part. The rack will slip forward and act like a launching mechanism hitting a projectile that's in the barrel. So that's kind of what the CAD model shows. So let's see if we can actually get it to work here. Boom, cannon. So that's how that works. And so we don't need to show this video. So that is pretty much our design. Are there any questions that you may have?
Is the cannon tip able to tilt up and down?
The cannon is not able to tilt up and down. We decided with the amount of materials and everything that we had that we either wanted to have it tilt up and down or swivel back and forth, and we chose to rotate 360, but that would have been a cool feature too if we could have added it, but we had thought about it.
This is all done with, into this class, all that was the 3D picture?
Some of it, the yellow parts, and then these fancy details on the side, we're done with the 3D printers, but we also were able to use laser cutters, and the body was pretty much all made out of acrylic. The barrel's aluminum. So we used a few different manufacturing methods.
I like the details.
Yeah, thank you.
Obviously, you like the tech.
Yes.
Good story.
Thank you.
What is the most difficult part in your catalog?
Max, you want to talk about that?
Probably the most difficult part was combining the spur gear with the bevel gear system. Basically, the bevel gear is made directly onto the spur gear as one part. So getting all of that to line up with each other, making sure it's supported enough so when the torque from the rubber bands acting on the gear, it wouldn't destroy everything. That was kind of the hardest part to get right.
What is your shooting range?
That was it.
Doing initial testing, we got it a little bit farther. It shoots about 3 feet. There's a lot of internal resistances and everything.
And the plastic, the 3D printer plastic's pretty brittle, so the teeth were starting to break. So that was probably the last time that'll be able to fire right now. So we'd have to find a different way to make the gears. Any other questions?
What's the rationale that you done more degree freedom on the side?
Well, I forgot to mention that in marketability. Well, so the train would come with a few sections of track, but if you wanted to go farther, you'll have to buy more track. And you can have curved sections of track, so you can make like a loop. We did not laser cut any of those, but it has the ability to do so around curved tracks. Any more questions? All right.
How would you improve your design?
Picking better materials for the gears. Obviously, 3D printed plastic's good for prototyping, but it's not great for actual use. So some kind of a metal